one. Okay, so what we're going to do today is chapter 10, add, subtract, multiply, and divide, positive and negative numbers. And just so that you know, if you hear a lot of noise going on in this recording, we're remodeling part of this house, and they are literally taking walls down next door. So that's a problem. But we'll see. So, we've been doing number lines, like this, where you'd start at 0 and keep going. But then what happens over here? Well, it's not like it drops off the cliff. It literally continues. And so the next one would be -1 and -2. And it can go on forever too, because you can keep going more and more negative. So we start by dealing with what happens if you're adding, but one of the numbers happens to be negative, or both of them, who knows? And so we want to figure out what to do. So I'm going to start with adding. Okay. And so I'm going to look at 4 scenarios. The first one, of course, is one you're familiar with. If the 2 numbers are positive, then you just add them normally. But let's say it's clearly addition, but one of the numbers is negative. So how do you think about it? Well, it depends. When you have a negative number, and this negative sign can be a number over here. And so, or there's actually 3 possibilities for this sign. One is to mean subtract. 2 is to mean a negative number, like -3. And 3 it's used to say the opposite. So what would be the opposite of +3? Well, the opposite of +3 would be -3. In the same way, the opposite of -4, okay? Opposite, on the other side of the number line, the opposite of -4 would actually be +4. And so we can use opposite in terms of this with the subtract, the negative numbers. And so that's where we're at. So what would this be? Well, it depends. If you had 3 and then to it you added a -2, the answer would be 1. Now you can think of this in terms of checkbooks. If you had $3 or what's in your pocket, you had $3, but then this is basically spending 2, you would be left with 1. Is that okay? Now, 10 plus -12. Now, I probably told you that I taught math in the state of Maine. And if you know anything about that state, it's very cold in the winter. So students really understand this concept of what happens when it was 10 degrees, this is Fahrenheit, and then it dropped 12. Now, can you tell very clearly that if that was the case, you would be below 0? The question is, how far below 0? Well, I mean, if I turn this number line on its end, and you started with a +10, which would be up here, but when you drop 12, you go below 0. Now, people understand that perfectly. And around here, it doesn't happen that often, but there, boy, they get it. It's like, oh, it's cold. You know, going to worry about the pipes or something like that. So the question is, how do you do this? Well, when one is positive and one is negative, you actually end up subtracting the two numbers. 12 take away 10 is 2. But guess what? Which sign is the one that takes over? It would have to be -2, remember? Because we took away more than we had. So you can reckon it to your checkbook. When you have $10 and you wrote a check for 12, you're in trouble, right? You're below 0. Or the temperature, whatever works for you. But this is definitely, so when one was positive and one was negative, you end up really subtracting the two, the 3 and the 2. And then the sign, whether it's a positive or a negative, is determined by which one is larger. So in this case, we had a +3, but a -2. So the 3 is the winner. And so it ends up being positive. Now, when there's no sign in front of it, we assume that's positive. So this one was +5, although we usually just say 5 because you know how we are. This one was 1, but it's also +1. But this one, wait a minute, we had to indicate that this is below 0 and this is -2. Okay. So the last one is this, and this really has to do, this works really well with temperature. If you had a temperature starting out of -5, so here's 0 and here's -5. But then this is indicating that the temperature drops some more. This is called a very bad day. Correct? And so if it drops some more, it's going down, right? And so it's even further from 0. And so this is 8 and it's -8. Does that make sense that it would take you down to -8? So when you look at the pattern of this, when they were both positive, you added and called it positive, right? When they were both negative, you added it and called it negative. Now, if you want to think of checkbooks or you want to think of temperature and pretend you're in Maine, fine. But that is a pattern for this one and this last one. Now, these two here, the two middle ones, this is one positive and one negative. You end up subtracting the two numbers without the sign. It's called absolute value. We subtract 3, take away 2 is 1. But the sign is determined by which of the two are larger. The 3 is larger than 2. So it ends up positive, but I think you can see that makes good sense. This particular one, we're subtracting 12, take away 10 is 2, but guess what? The bigger one was negative, and it ends up being negative. So whatever floats your boat, and there's other ways, I mean, you can memorize rules, you can think about temperature, but whatever works so that you always get these right, that's what really matters. So when you go to larger numbers like this, there's no way you're going to click off 125 little points here. So you've got to deal with this. You were below 125, and so it's almost like you owed 125, but then you paid back 50, so you have 50 to the plus. This is this middle rule where you subtract 125 minus 50. 125 minus 50 is 75. That part's right. But then what sign does it have? Which one is bigger? And the bigger one is the negative one. And so it's still, you're still in the negative zone. You just don't owe quite as much as you did before. Does that make sense? So we're dealing with paying back a loan, that would also work. Notice that every last one of these was addition, okay? The problem was clearly marked as addition. And so this is how you make this rule work. And okay. All right. Now, the interesting one is subtraction. Okay. This one, what we're going to do in most cases is convert it to addition. So when you do that first section of addition, and you get the idea of if they're both positive, it's positive. If they're both negative, you add them, it's negative. And if there's a positive and a negative, then you subtract their numbers and give the sign to the larger one. But with subtraction, we've got an extra thing going here. And so in order to convert it to addition, we're going to have to do two things. So here's 7, subtract 5. And I'm using parentheses not to say multiply, but just to separate out my two numbers. You will find that they will use parentheses more with positive and negative numbers. And the reason becomes, and I'll show you basically like this. If I wrote it like this, there's something awkward right here about that. A plus, a minus, what are you talking about? So that there is this tendency, this is not a mathematical thing. This is to help you see the problem correctly. This is artwork, if you want to call it artwork. So that clearly you can see it's 2 plus a -6. It makes it easier to see it. So knowing that, can somebody say what the answer is? Anybody? Yeah, it's a 4. Which kind?
-4.
Negative. Good job. Okay, is that all right? So when I overdo parentheses, it's not to say, oh, multiply, multiply. No, I'm trying to clear this up. And so in this problem, I'm doing it for a specific purpose. So everybody knows what 7 take away 5 is. But to convert it to addition, I would do this: 7 plus -5. Well, from the first section of addition, we figured out how to do that. In many ways, this is what subtraction really is anyway. You have a 7 and you're going to go back 5. So if you're on a vertical line, you would go down 5 from 7. And what your answer then would be 2. Now, why do I say convert it to addition? Because addition makes more sense than subtraction. And so it's probably the safest thing to do. So notice what I did. This is really critical. The first number did not change, ever. The subtract sign went to addition, and this went to its opposite. So the 5 in this parentheses was plus, it went to minus. So we're going to add. So somebody would say, oh, okay, summarize this for me. To do subtraction, we're going to add the opposite. Add it. Okay. So after a while, you get so good at these, you're not even thinking about this. But when you get started, you have to think about it until you get to the point where you can see what's going on no matter what. So let's try this one. -8 subtract -3. So once we start throwing these negatives around, then fixing this to addition is gonna really help. And so what do? We can clearly see it subtract. You see, that's the sign that says subtract. This sign is telling us -3. This sign is telling us -8, but this is subtract. Or if you like, do the opposite of -3. That's another interpretation. So what you would do is the first number is copied perfectly. Don't change it. The subtract goes to plus. And this number goes to its opposite. Now I could say +3 or just leave it 3. Now I'm into an area where I'm familiar with addition. And so now once I've cleaned this mess up, I can deal with this. I have -8 plus +3. And so they're opposite signs. So I subtract the numbers. 8 take away 3 is 5, but what kind of 5 is it? That's what you're saying. So you've got the 5 down, but that's not all of it. The larger number was negative, and so it ends up negative. Can you see that if, keep relating it to something you know. If you owed $8 and you paid back 3, you still owe. Right? You still, but you're better off than before, but you're not to 0 yet. And so that's now 9 subtract -4. It's clearly subtract. Look at how funny this would look without the parentheses. Let me just show you. So see what that looks like? Doesn't it look like somebody got carried away? You see what I'm saying? This is, it's like, I don't like that. But this, now you can clearly see it was 9. It was subtract, it was -4. And so now we say, okay, I know what to do with subtraction. I copy the first number. I make it an addition problem. But when I make an addition problem, this has to go to its opposite. So -4 goes to +4. At this point in time, you then say, how do I deal with a 9 plus 4? Well, it's too positive, so just do it like you always did. And what I'm trying to point out is this little piece here. When you subtract a negative and you do this little game of changing it to add the opposite of the negative, which is positive, every time you do that, subtract a negative or do the opposite of -4, it ends up being that little piece, the opposite of -4, ends up being positive. Can you see it? And so actually one method of teaching this is when, and there's all kinds of ways, but the 2 minuses, subtracting a negative, one method is just to circle those 2 and say plus. Because the 2 negatives will always be positive when they're in this, like this. And so either you follow the rule of changing it. Hi, Charles, go ahead.
I'm curious how, like, in what scenario you would say, like, I have 9 something and then I'm going to subtract -4 of something. Like, how is it applicable in life?
Well, it's going to come up. I'm going to have to think of a beautiful example.
Okay.
But we're going to have, formulas are going to require us to use the opposite of a negative.
Right.
And so this is the hardest to visualize.
Mhm.
One, and I know you asked for real life, but I'll try to give you something that sort of helps. Here's 0 and here's 9. And now I'm supposed to do something with a -4. Normally, -4 would take me this way, making it lower. Subtraction reverses, instead of going 4 down, right? Subtraction actually turns you around. So it's sort of like you normally would have marched down with a -4, but now you march up. Did you like that or not? Yeah, maybe.
I have a question.
Yeah.
What about -9 minus -4?
You want to do that one? Yeah. See, when you're swimming around in all these negatives, fighting for your life, right? You're going to need some rules. And the answer to this is not obvious at all. And so you remember the rules. Oh, it's subtraction. I'm going to make it addition.
Oh, yes.
Then you say, oh, the first number never changes. Because people change the first number and forget the second number. Nope, you change the second number. Then, regardless of which approach, there's this, which is plus, or add the opposite. But no matter how you shake it, it's going to be a +4. So you've turned a mess into that. Now it's addition. And addition, I think, makes sense.
Got it.
And so one positive and one negative, you end up subtracting.
Negative.
And so it's negative and it's 5.
All right, thank you.
Yeah. I'll think of some beautiful examples, Charles. The problem goes back to this. The problem goes back to my first picture. Can we function only this far, starting at 0 and going down? We can't. There's too many times when we have to go negative for whatever reason. And so once we go negative, then we have to learn the rules, just like learning the alphabet. You have to learn the rules of negative numbers. Okay, as I still haven't satisfied you, but that's, yeah.
Yeah, I guess it's just like I understand. So the rule is subtracting a negative is addition.
Exactly. For 2 different ways to do it, but it's definitely that.
It doesn't work the other way around. Like you can't, like when you add a positive, you get addition, but when you subtract a negative, you get a positive.
Yeah.
Okay.
Yeah. Okay. So I understand subtraction. One, it leaves you feeling, I'm not sure about this. I suppose in your okay, I got it, Charles. You bought something with a credit card for $52. So the statement reads -52. It may not have the minus on it, but it's clearly, it's a negative. Okay, and many times it will have the negative. But let's say you mail it back. Forget the postage, because I know they're going to get you on that. But let's say you decide you don't want it, you're going to return it. Now, what happens is they have to reverse this. So to reverse this $52 that's in the negative, you have to reverse it. You have to do the opposite of that negative 52. So
right.
basically you get a credit. So now your statement is reconciled. Do you like that?
I'll accept it.
Okay. I had to try. I'm a little
Yeah.
distracted here, but
No, thank you.
but yeah, this, I think you've got the opposite of a negative. It's the same thing as what we're talking about. Now, the good news is the following: multiply and divide not only are easier, but they're identical for their rules. So once you learn one, you've got 2 for 1. And so let's run through some problems with multiply. So if I have 3 times 5, I wrote it like that. That's a positive 3, that's a positive 5. This would be 15. Charles? Did you raise your hand? Oh, okay. So what would happen if I did this? 3 times negative 5. Anybody want to guess what that is?
Negative 15.
Yeah. And so you could make a little story out of this. If you borrowed $5 3 times, negative 5, negative 5, negative 5, you would now be at negative 15. This is multiply, remember. Now, it really doesn't matter whether the first one's the negative or the second one's the negative. It's going to turn out the same thing. So in this case, we borrowed $3, but we did it 5 times. How much is it?
Negative 15.
Same thing. Now here's the cute one. Ready? Negative 3 times negative 5. There really are 2 negatives here in multiplication, negative and a negative. What is our answer?
Positive 15.
It is positive 15. So now this is our basis. This is where we're going to work from. So is there a pattern? And so I want you to see these 2. When it was 2 positives, it's positive, like it always was. When it's 2 negatives multiplied, a negative times a negative, it's a positive. But when it's a positive times a negative or a negative times a positive, it ends up negative. So what's happening is 1 negative in multiplication makes it negative, regardless of which one. But 2 negatives in multiplication makes it positive. Now this extends if I had so there is a pattern here. So 1 negative made it negative. 2 negatives made it positive. What do you think 3 negatives will do?
That would be negative.
It's going to be negative, so it flips back and forth. And so let's say we actually did this problem out, because you do it 2 at a time. So if you multiplied this by this, negative 2 times negative 3, we've got the rule down, it's positive 6. Positive 6 times negative 5. It's this rule. What is it?
30. Negative.
Yeah, and it's negative 30. So And I wanted to just extend it so that you can see what's happening. Usually it's just 2 at a time. But literally, if it's all multiplication, you can literally count the negatives. 1 negative would have been negative, 2 negatives would have been positive, but 3 back to negative. And so one way to do this particular problem is just to multiply the numbers. 2 times 3 is 6, 6 times 5 is 30. But then what? 3 negatives will make it negative. And so eventually you'll be cutting corners and counting negatives and so on, if it's all multiply or even divide, because the rules are identical for divide. So let me start here. 10 divided by 2 is 5, 2 positives, and it could look like this. Either division line with a fraction or this division, but both of those 2 positives stay positive. But if you have 1 negative divided by a positive, the answer is still 5, but it's the 1 negative makes it negative. And it doesn't matter whether it's the numerator or the denominator. It still would be 5 negative. But you know where I'm going. This last one, negative 10 divided by negative 2. Well, not only do you have to realize that 10 divided by 2 is 5, a negative divided by a negative is a positive. If you look at these 2 examples, I mean, there's two groups. This division and this multiplication are identical in structure. 2 positives, positive, 2 negatives, positive. But 1 negative in division, negative. Same exact. So once you get this down, you've got this down. So multiply and divide are the easiest, and it probably was, remember when we did fractions, it was the same story. The multiply and divide was easier than the add and subtract, strangely enough. Okay, that's what this chapter is about. And so how many, when you go ahead and take the next course, which is going to be the beginning of algebra, how many of these problems, add, subtract, multiply, divide? 1 million of them. And so what they want is you to get really good at this before then. You know what I'm saying? Because if you keep messing up, if you lose your sign or you know something, it's just gonna be that you're gonna lose too many points. And so that's what we really need. I'm gonna find us some problems to do. How are we? Okay, I'm gonna go to the end of this chapter. Oh, let's try this one. We did powers before, didn't we? So notice the use of the parentheses to say it's -6 that's squared. So this would be -6 multiplied to -6. Why did I write it twice? Because I don't want you to lose the fact that 2 negatives will make it positive. And 6 times 6 is 36. The fact that it's -4 3 times, it would look like this: -4, -4, -4. 1, 2, 3 negatives. That's why I showed you that. The first 2 negatives goes positive. The next one takes it to be negative. And now you have to figure out the number. So 4 times 4 is 16. And then that's 16. And then 16 times 4 is
64.
64. So notice this pattern here. When I had the -6 times the -6, it ended up being positive. When I had the -4 to the 3rd power or cubed, 3 negatives made it negative. And so you need to have these different things. Here's a problem. Okay. So I'm looking at some of these problems. This is a -4, it's addition. This is 5 times this. So what's done first, of course, is what's in the parentheses. So -6 plus 2. This is clearly addition, so you don't need to be fooling with it. You just need to come up with an answer, 1 negative and 1 positive. You end up subtracting the two numbers. 6 take away 2 is 4, but what kind of 4?
Negative.
Negative it is.
So
And
it's 4.
I'm gonna put the 5 outside and then the plus the -4. So by order of operation, I still have to do this next because
Oh,
this is multiply. So a +5 times a -4 is -20 plus -4. Now here I have this problem of the plus and the minus. I did put a little space here to try to help things out. But in some ways, they might have included parentheses so that it's extra clear that it's a -4 plus a -20. With addition, you don't need to be changing anything. You just need to do it. This is that very bad day scenario, or a very bad thing with your bank account. You owed $4 and then you wrote another check for 20 or used it. And so now you're really in the hole.
Yeah.
Right? And so you end up the 4 and the 20,
-24.
-24. Okay. So you took this, you did this first, and that improved it. You then saw this was multiply, which is a lot higher in priority than this adding. So we did this next. I put the parentheses down only for a visual thing. I could have avoided it, but I thought it made it clearer. When you have signs stacked up next to each other, I think it helps. And then you had a negative and then more negative. That does not make this positive because this is addition. This just takes you further down the hole. Or, boy, that if the temperature dropped 20 degrees. Wow. When you were already below 0. Can you see it? I think now we're in Alaska or somewhere. Okay. We don't want to go there. Maybe you do. I don't.
I have a question.
Go ahead.
When you have a number and then you have a negative power.
Oh, we're not going to do negative powers yet, but we will.
Oh, okay.
Negative powers forces the problem to be a reciprocal. So we should see that, but not yet.
All right. I just
Yeah,
see him
but
before.
you're thinking ahead because once you start to realize you can work with negative numbers and you have positive exponents, then you can have negative exponents.
Oh,
And you can have exponents that are fractions.
wow.
You can do all kinds of things. So we don't want to get too carried away. So here's one, -4, +3, -2. So this is the multiplication deal. Notice I can count the negatives. Because there's times when I would like give people credit for getting the right number, but the wrong sign. But what is the right sign? 1 negative, 2 negatives. What kind of sign do we get?
Positive.
It's going to be positive. So at this point in time, once we determine it's going to be positive, I could put a plus there or just ignore it. Now I have to multiply. 4 times 3 is 12. 12 times 2 is 24. And so it might help to separate out your decision about what is the sign with what is the number. The number is 24, but is it positive or negative? 2 negatives, it's positive. Now I'm going to show you something. Ready for this? I have seen this mistake 4 courses above this because students have trouble with this concept. And so each time you take a class, they're going to bring it up again and again, until you say, okay, I get it. Are these two the same? And the answer is no, they're not. So this one with the parentheses is clearer because we already did it. It's a -5 times a -5, right? Because the parentheses is defining how much you're going to multiply, what number you multiply twice. So a negative times a negative is a positive. 5 times 5 is 25. So that part should make sense. And then we look at this one. Without the parentheses, the only thing that's getting squared is the 5. The 5 is the base. The 2 is the exponent. And this is basically a subtract or like a -1 or something. And so literally what it turns out to be is -5 times 5. So without the parentheses, the only thing that's squared is the 5. See, the parentheses let you bring the negative in twice, but without it, it's 5. And so 5 times 5 is 25. The opposite of that would be -25. How many times?
The parentheses kind of saying there's something to solve, and then the one without parentheses is basically saying this is what it is.
Yeah, let me expand this problem just a little bit. If you had this problem instead of the one above, it would be really clear to just go 5 squared is, right? 25, wouldn't it? And then 100 take away 25 is 75. Did I answer your question? Without the parentheses, the only thing that's squared is the base number. And
So the
so
minus is not glued to the 5.
it's not glued to it at all. In fact, one thing you could do is think of it as, some students think of it like that minus is like a -1 multiplied. And then you would know what to do. You would do your exponent first, which is 25. You would then multiply it by -1, which would end up negative
Gotcha.
25. But honestly, I've seen this class as high as calculus, this error is high as calculus, because it's, when you're not paying attention to this, between this and this, it's just like, what I want to do is set up a red flag for you when you see these problems, that you say, wait a minute, what am I supposed to do? Don't, take your time, okay? Take your time. Now, here's a cute one for you. This one here involves both multiplication and division. The good news is that multiply and divide use the exact same rules. So the fact that there are two negatives multiplied means that this number is going to be positive. So if you need to, establish that straight off the bat. And so then you don't have to worry about the sign. So it's really 4/5 times 15 over 28, which I think is good. The 4 and the 15 can reduce 5 into 5 once, and this would be 3 times. The 4 and the 28 reduce 4 into 4 once, 4 into 28 7 times. The two negatives make positive. We already established that. So 1 times 3 is 3. 1 times 7 is 7. And so when you put that answer in, you would probably just do that. Now I bring this problem up because I don't like the way they did this. So if I wanted to say negative 4/5, there is a tendency in the book to put the negative sign right there, level with the fraction line. Another thing to do is to put the negative in the numerator. That would still make it negative. The third thing to do is to put the negative in the denominator. This last choice is considered poor form and nobody likes it. And so this should be avoided. So leaving a negative in the denominator, don't ever do that. It's just like you don't want to make that terrible mistake. I prefer the middle one because there are advantages further down the road to bringing that negative to the numerator. Let me show you this problem written the way I would normally write it. It would have been negative 4/5 times negative 15 over 28. The problem with this approach is people are thinking, well, there's a negative here, but does it go to the 4? Does it go to the 5? Does it go to both? If it goes to both, then it's positive. A negative divided by negative is positive. So we're not clear. So I tend to write them like this, where the negative is in the numerator and like that. Again, I see two negatives. In multiply divide, it's going to be positive. I don't have to say so. I can reduce the numbers. Okay. This is just a suggestion, but there are times, and it may even be the next course, where this approach helps save the day. And so that's why I put it that way. There is a tendency in the book to do this approach. They're both the same thing. It's just one I find easier to work with. Okay, let me see. Let me find some more. How's our time? So they just want you to do these problems until you're blue in the face, until you're getting these problems correct. And so getting them right half the time is not good enough. Getting them right all the time is what you need. That's all there is to it. You hate to give away points for a tiny little sign, right? And so in this case, you know, some of these you can do without making a fuss about it. For instance, 3 take away 7. Obviously, you didn't have enough to subtract 7, did you? Can anybody see what that is? Just that problem?
-4.
It is -4. It's using the same rules, but we definitely went below 0. And how much did we go? We went 4 below 0. Same thing with this. 2 take away 8, we're below 0. So -6. So my suggestion is if you can see what it is very easily, then just write it and don't make a fuss about it, the plus, the minus, all that stuff. If you can see it, just nail it. But now you're almost done, but you have one more step. This is now multiply these two numbers. And so you say, okay, I look at my page that gives me what to do. A negative times a negative is a positive. And of course, the number part is the easy part, 24. Okay. Let's see if I can find one for us. Okay, this is a different problem. This particular one, there's negatives involved, but this parentheses actually has something to do. So in this one, you're just admiring, what a lovely -3. Oh, I love that one, right? I love that negative, or -2 rather. Such a nice one. But there's nothing to do but admire it. But over here, I've got something to do. So let's do it. 6 subtract 7. So again, if you can see what it's going to be, just write it. You're going to go below 0. By how much?
1.
Yeah. So I'm copying that and I'm copying that. So now this is a fraction, which is actually division. This is multiply, this is multiply. We see 2 negatives, and so we know it's going to be positive. You don't have to write the plus sign, but I did. Then you ignore all the minuses. And I actually could cancel this 2 with that 2. Three times 1 times 1 is 3. 1 times 1 times 1 is 1. So this became 3 over 1. And I would just say 3. I would take away the plus sign. I don't need it over 1 for the answer. How's that? Here's a word problem. Colin used his debit card for a checking account to buy 2 dozen glazed donuts. The bank will deduct 85 cents from his checking account. What is the total amount the bank will deduct? So is it 85 cents for each donut? Oh, okay. All right. Please read. Is a donut 85 cents? Not in Seattle. What does a donut cost in Seattle?
Like $5.
How much?
Like $5.
For a donut? Yeah, you can. Some of the donut stores. Okay, let me
Expensive.
read this again because I didn't read it properly. Okay. He's going to buy 2 dozen. Okay, which is 24. Each one is 85 cents. So that's 1. We want to know how much it's going to cost altogether. So this needs to be multiplied by what, 24? Now, oh, hi, just a second. Yep.
I have to take off. I have another appointment,
Okay.
but I just wanted to show you real quick.
Okay.
Yeah.
Oh, okay. Yeah.
Yeah.
Okay. tomorrow?
I'm not sure if I'm gonna be here. My mom and brother just came up from Colorado. I haven't seen them for 2 years, so,
Okay,
but, I think it's Friday, I will be back.
okay, all righty.
But yeah,
Okay,
All right.
thank you.
yep, have a
Yeah,
good night.
thanks. Okay, sorry about that. So they were interested in what's gonna happen to the bank account statement. And so they're not gonna give you a credit for this, are they? Just because you like donuts? They're gonna subtract, right? So it's actually, technically, it's a -85 for each donut times 24. So you multiply that out, and I'm just gonna pull my calculator.
20.4,
How much?
20.4.
Yeah, 20.40. But what kind of sign do we have?
Dollars.
It is dollars, but
Oh,
it's basically gonna be a debit. It's gonna be they're subtracting it out of your account, aren't they? They're not paying you to buy donuts. Hey, Charles. I see your hand. Is your hand up?
No, it's not. I think it just never came down.
Okay. I just noticed, I just looked up and I said, oh, I think that, I have no idea. Well, I suppose I don't know. Anyway,
Yep.
it's a negative number, isn't it?
oh,
In other words, you bought donuts, they're not gonna give you a plus, they're not gonna, give you a plus for that. Okay,
I will buy them.
you would buy them if they
They're
would.
cheap.
I know, I've sort of given up that stuff. Suppose, here's another one. This is about a ship. Suppose an ocean-free diver descends at a rate of 3 feet per second. What negative number represents the diver's depth after 60 seconds? Okay, so here's the water, 3 feet a second. My picture's out of there. So 3 feet for each second times 60. So how do I write that with the positive and negative numbers and get an answer?
Is that -60?
So how much did you say?
-60?
Well, it's 60 seconds, but you're losing 3 feet every second.
Oh, okay.
So it's 3 feet times 60. That's 180. But then they want to know, they want to realize that you're going down. And so this is the 3 feet, this is down 6. This is down 9 feet. So this would actually be your down 180. So it's a way to explain being below sea level. How's that? Okay. Well, I think that's where we are. Let's take a look at our. So there, the assignment looks like this. Let's see if I can find it. The first 2 sections are due. Here we are, calendar. So I bring this up for 2 reasons. One, 10.1 and 10.2, the first 2 sections of chapter 10 are due tonight.
Mhm.
If you don't have time to do them, use a late pass for each one. The rest of this is due Friday, and so we'll just do this positive, negative numbers this week and then move back to chapter 5. Now, for one student, I did give them the chance to do the chapter 3 and chapter 4 review. You may have noticed that this was extra credit. That's the way I marked it. And so it's still good. You could, if somebody didn't do it and they think they may need extra credit in the near future or sometime, that's still an option. I just wanted to show that to you. I asked you to do the reviews at the bottom of XYZ homework. I don't know if everybody did it. I really didn't check. But then after I said that, I marked it as extra credit. So that's an option for you to do if somehow that might float your boat. And then next week we'll be back on schedule. So we'll have Monday, Wednesday, and so on. And we'll be working on chapter 5. Okay. Any question about the schedule? So the 2 things due tonight, but use a late pass if there's not enough time, but if there is, do it. And then the rest of this chapter is due on Friday night. Any question about that?
When I use my late pass, do you take points away?
Nope.
Oh,
Nope.
because
Feel free and ask for more if you need them.
I have some papers to turn into the.
Okay. Yep, let me stop the recording.